We have already learnt about some of the algebraic methods to solve a pair of linear equations in two variables in our earlier classes. Now, let us try to solve a real-life situation using one of the known methods. Look, Joe and Peter are at the coffee shop discussing about their financial status. Joe says, "Give me 100, friend. I shall be twice as rich as you." Peter replies, "You give me a 10, I shall be 6 times as rich as you." Can you guess how much money do Joe and Peter have? Let rupees X be the amount of money with Joe, and let rupees Y be the amount with Peter. We can form algebraic equations from the above conversation, and the equations can be written as x plus 100 is equal to 2 into y minus 100, and y plus 10 is equal to 6 into x minus 10. Simplifying the two equations, we get x minus 2y plus 300 is equal to 0. Consider this as equation 1. "6x minus y minus 70 is equal to 0. Consider this as equation 2. Now, let us use the elimination methods to solve these equations. Multiply equation 1 by 1 and equation 2 by 2 to make the coefficients of y equal. Then we get the following equations: 1 into 1x minus 1 into 2y plus 1 into 300 is equal to 0. Equation 3. 2 into 6x minus 2 into 1y minus 2 into 70 equals 0. Equation 4. Subtracting equation 4 from equation 3, we get 1 into 1 minus 2 into 6x minus 1 into 2 minus 2 into 1y plus 1 into 300 minus 2 into 70 equals 0. So, the value of x is equal to minus 2 into minus 70 minus 1 into 300 whole divided by 1 into minus 1 minus 6 into minus 2. If the equations 1 and 2 are written as a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then we have a1 is equal to 1, b1 is equal to minus 2, c1 is equal to 300, a2 is equal to 6, b2 is equal to minus 1, and c2 is equal to minus 70. Then equation 5 can be rewritten as x is equal to b1c2 minus b2c1 divided by a1b2 minus a2b1. Similarly, we can get y is equal to c1a2 minus c2a1 divided by a1b2 minus a2b1. Simplifying equations 5 and 6, x is equal to minus 2 into minus 70 minus 1 into 300 whole divided by 1 into minus 1 minus 6 into minus 2. Simplifying the equation and solving for x, we get x is equal to 40. The value of y is equal to 300 into 6 minus 1 into minus 70 whole divided by 1 into minus 1 minus 6 into minus 2. Simplifying the equation and solving for y, we get y is equal to 170. This is cross-multiplication method of solving pair of linear equations in two variables. Do you observe any relation between the coefficients and the type of solutions obtained? Yes. Here, the pair of linear equations has a unique solution, since the value of the denominator is not 0, that is, a1b2 minus a2b1 is not equal to 0. This can be expressed as a1 by a2 is not equal to b1 by b2. Thus, when a1 by a2 is not equal to b1 by b2, we get a unique solution. Let us now see how the system works for a pair of linear equations in two variables expressed for the general form. Step 1. Write the given equation in the general form. a1x plus b1y plus c1 is equal to 0, equation 1. a2x plus b2y plus c2 is equal to 0, equation 2. Step 2. Take the coefficients of a1, b1, c1, a2, b2 and c2 and draw arrows that cross each other between the numbers. The arrows between the two numbers indicate that they are to be multiplied and the second product is to be subtracted from the first. Step 3. Taking the help of the cross multiplication diagram, write the equations. By cross multiplication method, we can write the solution in the following form. X by b1c2 minus b2c1 is equal to y by c1a2 minus c2a1, that is equal to 1 by a1b2 minus a2b1. Step 4. Find x and y. So, x by b1c2 minus b2c1 is equal to 1 by a1b2 minus a2b1. Or y by c1a2 minus c2a1 is equal to 1 by a1b2 minus a2b1. Solving for x and y, we get x is equal to b1c2 minus b2c1 divided by a1b2 minus a2b1, and y is equal to c1a2 minus c2a1 divided by a1b2 minus a2b1. This is cross multiplication method of solving pair of linear equations in two variables. Now solve the system of equations. 3x minus y is equal to 2, equation 1. 15x minus 5y is equal to 10, equation 2. Let us try solving this by substitution method. Equation 1 can be rewritten as y is equal to 3x minus 2. We substitute the expression for y in the second equation. To get 15x minus 5 into 3x minus 2 is equal to 10. The substitution results in an equation in one variable. 15x minus 15x plus 10 is equal to 10. Applying the distributive property and simplifying. This does not give the values for x and y. Now let us try elimination method. Multiplying equation 1 by 5 and equation 2 by 1, we get 15x minus 5y is equal to 10. 15x minus 5y is equal to 10. Subtracting both the equations, we find that the result is 0 as both the coefficients get eliminated. This too does not give the values of x and y. Now, consider solving the pair of linear equations using the cross multiplication method. The equations are rewritten by bringing the coefficients on one side. 3x minus y minus 2 is equal to 0, equation 1. 15x minus 5y minus 10 is equal to 0, equation 2. We notice the coefficients are a1 is equal to 3, b1 is equal to minus 1, c1 is equal to minus 2, a2 is equal to 15, b2 is equal to minus 5, and c2 is equal to minus 10. Now, taking the ratio of the coefficients, we get a1 by a2 is equal to b1 by b2, that is equal to c1 by c2, that is equal to 1 by 5. So, the system has infinitely many solutions. Thus, cross multiplication method helps us to check whether the system of equations has unique solution, infinitely many solution, or no solution. Now, let us solve a real-life situation using the method of cross multiplication. In a deer park, the number of heads and the number of legs of deer and human visitors were counted, and it was found that there were 39 heads and 132 legs. Find the number of deers and human visitors in the park. Let us represent deers by variable, say, x, and humans by variable y. According to the statement, the total number of heads of deer and number of heads of humans is 39.
This can be written algebraically as x plus y is equal to 39, or x plus y minus 39 is equal to 0. Let us consider this as equation 1.
It is also given that total number of legs of deer and number of legs of humans is equal to 132. Since a deer has 4 legs and humans have 2 legs, it can be expressed algebraically as 4x plus 2y is equal to 132. That is, 4x plus 2y minus 132 is equal to 0. Dividing the entire equation by 2, we get 2x plus y minus 66 is equal to 0. Let us consider this as equation 2. Arrange the coefficients of constants and variables as shown in figure. Using the above equation and cross-multiplying, we get x by minus 27 is equal to y by minus 12, that is equal to 1 by minus 1. On simplification, we get x is equal to 27 and y is equal to 12. Thus, in the deer park, the total number of deers is 27 and the number of human visitors is 12. Suppose the pair of equations are of the form 10 by x plus y plus 2 by x minus y is equal to 4 and 15 by x plus y plus minus 5 by x minus y is equal to minus 2. Are these pairs in linear form? How would you solve them? No, the equations are not in linear form. They can be solved by converting into linear form. Here, let us put 1 by x plus y is equal to p and 1 by x minus y is equal to q. So, the given equations can be written as 10p plus 2q minus 4 is equal to 0. Consider this as equation 5. 15p minus 5q plus 2 is equal to 0. Consider this as equation 6. Taking out the coefficients and cross-multiplying, we get p by minus 16 is equal to q by minus 80, that is equal to 1 by minus 80. This can be rewritten as p by minus 16 is equal to 1 by minus 80 and q by minus 80 is equal to 1 by minus 80. So, p is equal to 1 by 5 and q is equal to 1. Substituting values of p and q in equations 3 and 4 and simplifying, we get x plus y is equal to 5. Consider this as equation 7. And x minus y is equal to 1. Consider this as equation 8. Thus, we converted nonlinear equations into linear equations by suitable substitution. Adding equation 7 and 8, we get the solution for x as equal to 3. And subtracting 2 equations, we get y is equal to 2. Hence, x is equal to 3 and y is equal to 2 is the required solution to the given pair of linear equations. Now, let us verify whether our solutions are right. Substitute x is equal to 3 and y is equal to 2 in the given equations 1 and 2. We get LHS is equal to 10 by 5 plus 2 by 1, that is equal to 4, which is equal to the RHS. The solutions are verified. Thus, the pair of equations which are not linear can be reduced to their linear form by suitable substitution, and then the solutions can be obtained. A boat covers 32 kilometers upstream and 36 kilometers downstream in 7 hours. It covers 40 kilometers upstream and 48 kilometers downstream in 9 hours. To solve this, let the speed of the boat in still water be x kilometers per hour, and let the speed of the stream be y kilometers per hour. When the boat goes up the stream, it flows against the flow of water, and similarly, when the boat goes down the stream, it goes in the same direction as the stream of water. So, the speed upstream is equal to x minus y kilometers per hour. and the speed downstream is equal to x plus y kilometers per hour. We know that speed is equal to distance traveled by time taken. So, the time taken to cover 32 kilometers upstream is equal to 32 by x minus y hours, and the time taken to cover 36 kilometers downstream is equal to 36 by x plus y hours. Total time taken to go up and down the stream is 7 hours. So, 32 by x minus y plus 36 by x plus y is equal to 7. Let us consider this as equation 1. So, the time taken to cover 40 kilometers upstream is equal to 40 divided by x minus y hours. Similarly, the time taken to cover 48 kilometers downstream is equal to 48 divided by x plus y hours. As the total time for up and down the stream is 9 hours, 40 by x minus y plus 48 by x plus y is equal to 9. Consider this as equation 2. Here, the equations 1 and 2 are not in the general form of linear equations. They have to be reduced to linear equations. Putting 1 by x minus y is equal to u and 1 by x plus y is equal to v in equations 1 and 2, we get 32u plus 36v is equal to 7, which is rewritten as 32u plus 36v minus 7 is equal to 0. Let us consider this as equation 3. Similarly, 40u plus 48v is equal to 9, which is rewritten as 40u plus 48v minus 9 is equal to 0. Consider this as equation 4. By cross multiplication, simplifying the above equation, we get u by 12 is equal to v by 8, that is equal to 1 by 96. Solving for u and v, we get the value of u is equal to 1 by 8 and v is equal to 1 by 12. Substituting these values in the above equation, we get x minus y is equal to 8 and x plus y is equal to 12. Consider these as equations 5 and 6. Adding equations 5 and 6, we get x is equal to 10, and subtracting equation 6 by equation 5, we get y is equal to 2. Thus, the speed of the boat in still water is 10 kilometers per hour and the speed of the stream is 2 kilometers per hour. Rita travels 300 kilometers to her home partly by bus and partly by car. She takes 4 hours if she travels 60 kilometers by bus and the remaining by car. Let the speed of the bus be x kilometers per hour and the speed of the car be y kilometers per hour. Rita takes 4 hours if she travels 60 kilometers by bus and the remaining by car. Time taken by her to travel 60 kilometers by bus is equal to 60 by x. Time taken by her to travel 240 kilometers by car is equal to 240 by y. Here, it is given that the total time taken is 4 hours. So, the given condition can be algebraically represented by the equation 60 by x plus 240 by y is equal to 4. Dividing the equation throughout by 4, we get 15 by x plus 60 by y is equal to 1. Let us consider this as equation 1. When she travels 100 kilometers by bus and the remaining by car, she takes 10 minutes longer. Find the speed of the bus and the car separately. Here, the time taken by Rita to travel 100 kilometers by bus is equal to 100 by x per hour. Similarly, the time taken by her to travel 200 kilometers by car is equal to 200 by y hours. So, total time taken is equal to 4 hours 10 minutes, which is equal to 25 by 6. Writing this in algebraic form, we get 20 by x plus 40 by y is equal to 5 by 6. Let us consider this as equation 2. Since the equations are not in linear form, let us substitute 1 by x is equal to p and 1 by y is equal to q. So, the equations 1 and 2 can be rewritten in linear form as 15p plus 60q minus 1 is equal to 0. Consider this as equation 3. And 20p plus 40q minus 5 by 6 is equal to 0. Consider this as equation 4. Using the cross multiplication method, solving the equations, we get p is equal to 1 by 60 and q is equal to 1 by 80. Now, substituting these values back into the above equation, we get x is equal to 60 and y is equal to 80.
Thus, the speed of the bus is 60 km per hour and the speed of the car is 80 km per hour.